The tasks of managing the individual sections of the pipeline were assigned to particularly experienced men who had laid pipelines under all sorts of conditions in all parts of the world.
The actual construction activities themselves aren't the real problem, nor are the thousands of logistic tasks associated with such a project. Ensuring that everything is at the right place at the right time, setting up camps, offices, stores and repair yards, arranging accommodation and catering 1,500 people, supplying enough fuel for 700 pieces of construction equipment and vehicles, and provide facilities for serving and repairing them, tasks that are associated with every pipeline project. In this case, the environment we were working in simply did the necessary infrastructure to support a project of this magnitude. In numerous cases, we had to create conditions that had enabled us to actually get to the route before we could do any other work.
80 access roads with a total length of approximately 250 kilometers were required in order to move the heavy construction machines and the pipes to the planned route. In some cases, these construction roads had to be laid from scratch. In others, MPCC could use existing roads, although many of these had to be consolidated by being widened, stabilized, or regulated. The numerous small rivers and streams that had to be crossed were an obstacle in their own right. In order to make them passable for the construction vehicles, suitable fords had to be made and temporary bridges had to be built. The practicability of the access roads was tested automatically, as it were. If a grader couldn't go any further under its own power, then it was clear that there were still some improvements to be made. For months, proceeding as planned was the standard statement to be heard in the progress meetings held with the customer PGN, until August 1997, when the haze became the single theme that dominated all discussions.
The weather phenomenon El Niño was initially working in our favor. The rain that was expected held off, making it easier for us to work. But suddenly forest fires broke out everywhere, and it was impossible to get them under control. By the end of September, visibility had been reduced to 20 meters and the pollutants in the air had reached harmful levels. To continue would have been irresponsible, and we knew that we would have to evacuate.
Crisis management was now the order of the day for the MPCC project management team. However, the 6-week suspension due to haze wasn't the only unexpected event during this project. The monetary crisis in Southeast Asia confronted our subcontractors and suppliers with severe financial problems. But the situation was resolved, securing the success of the project. Then, in May 1998, the political crisis hit Indonesia, with riots also in Jakarta. Supplies of materials and funds were suddenly cut off, and as an intermediate solution, were relocated to Singapore. The project survived all of these crises, but valuable time had been lost. If the aspired completion deadline was to be met, the daily output would have to be increased by 40%, and so additional personnel and equipment were mobilized. The pipes were transported to the route using any sort of vehicle with wheels or tracks that was capable of safely moving pipes across difficult terrain. And not just the modern Challenger transporters with their gas-filled rubber tracks. The targeted daily output was 2,500 meters. This means preparing 2.5 kilometers of the route, transporting 2.5 kilometers of pipes, laying them out and bending them if necessary, welding them together, checking the joints by means of X-rays, insulating the pipeline and laying it in the trench every day. And that in a terrain that was anything but homogeneous. The stringing, which is the process of laying up the pipes and which calls for centimeter precision, was also done as rationally as possible, with challengers fitted with cranes and separate vacuum lifters used to unload the trucks. This is when the pipes lose their anonymity. Each one is assigned a number, and everything that happens to it from now on is meticulously documented. In many other sections of the route it was impossible to lay out the pipes. The banks of the rivers Siak, Nilo, Kampa, Indragiri, Batanghari and Lalang merge with extensive swamps.
Sometimes it was impossible to say where the swamp started and where it stopped, because the ground conditions and hence the accessibility of the terrain depend on the water levels of the rivers. The water levels, however, change continuously and could rise or fall by as much as a metre in a matter of hours. On the basis of the original project plan, we were expecting to lay just a couple of kilometres of the pipeline in swamps. However, detailed studies of the terrain showed that a total length of 80 kilometres of the pipeline could only be laid using the push and pull method.
Preparing the route in swamp sections was confined to digging drainage trenches and excavating the trench for the pipeline itself. So-called swamp buggies were used in particularly difficult areas. Their chassis construction with extra wide tracks distributes the load better and prevents them from sinking into soft ground. Building a pipeline under extreme geographical and climatic conditions always forces you to improvise. You have to be able to react flexibly when unforeseen problems arise.
On the Lalang River, we were faced with the following problem. How could we get the pipes across to the swampy side of the river onto a terrain that could best be accessed using swamp buggies, but not by pipe transporters? Building a long access road through the swamp would have cost a lot of money and resources, and we would have lost time. The only possible solution was to load the pipes onto a barge, one batch after another, and ferry them across to the other bank. We had already had this problem on the Batanghari, but in this case the water level had sunk so low that barges couldn't be used. We had to improvise. We sealed the ends of 1,500 pipes so that they were watertight, lashed them together in groups of 4 to make a raft, and then towed them across the river using small boats.
Let's go back to the hills. Some 70% of the route went through slope areas, a seemingly endless and sometimes very steep series of hills. The majority of the pipes had to be precisely bent to follow the exact rise and fall of the terrain. The extent to which the pipes were bent was determined on the basis of a precise survey. There is no economical alternative to cold bending large pipes. Using pipes that have been warm bent in the pipe factory is simply too expensive. 3 cold bending machines were brought in from Germany, and they came to grips with 2/3 of all the pipes as they wandered from hill to hill in the course of several months. The machines were routinely operated by master benders from Manas or Nakam. If bending machines could speak, they would surely pay their Indonesian operators a big compliment, because they performed their job equally well.